Welcome to this tutorial on random permutations with NumPy. In this video, you'll learn how to use the np.random.permutation function to shuffle and rearrange array elements randomly. This is a powerful tool for data preprocessing, machine learning, and statistical analysis. Before we dive into the code, let's understand what a permutation actually is. A permutation is a rearrangement of elements in a sequence where each element appears exactly once, but in a different order. Think of it like shuffling a deck of cards. All cards are still present, just in a new random order. Here's a simple example to visualize this concept. If we start with an original array containing 1, 2, 3, and 4, a permuted version might be 3, 1, 4, 2. Notice that all the original elements are present, they're just rearranged. Every permutation contains the same elements, just in a different sequence. The basic syntax for using this function is straightforward. First, import NumPy as np, then call np.random.permutation and pass in x as the parameter. The x can be either an array you want to shuffle or an integer representing a range. Let's see a practical example. We create an array containing the values 10, 20, 30, 40, and 50. Then we pass this array to np.random.permutation, which returns a shuffled copy. The output might be 30, 50, 10, 40, 20, a random arrangement of the original elements. Remember, the original array remains unchanged. There's another useful way to use this function. If you pass an integer n instead of an array, it generates a random permutation of numbers from 0 to n-1. In this example, passing 8 returns a shuffled array of indices from 0 to 7, like 5, 2, 7, 0, 3, 1, 6, 4. This is extremely useful for shuffling datasets while maintaining index relationships. The permutation function also works with multidimensional arrays. When you pass a two-dimensional array or matrix, it shuffles along the first axis, which means it shuffles the rows. The rows themselves remain intact, but their order is randomized. So if you have a 3x3 matrix, the function will rearrange which row appears first, second, and third, while keeping each row's internal structure unchanged. Let's recap the key points. First, np.random.permutation creates a new shuffled copy without modifying the original array, keeping your data safe. Second, you can pass an integer n to get a permutation of range n, giving you random indices from 0 to n-1. Third, for multidimensional arrays, the function shuffles along the first axis only. Understanding these behaviors will help you use permutations effectively in your NumPy projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.